Hey guys, this is Coach Lowe, and this is 9.2. We're going to talk about similar polygons. So 9.2, similar polygons. All right, so let's get started. All right, so first of all, when we talk about polygons, we're talking about a closed figure that's formed by segments. Closed figure, which means no open spaces around the edge. The sides will all meet. And it's formed by sides, so no curved edges. And the segments or the sides only meet at their endpoint, so they're not going to cross and intersect or anything crazy like that. So that's what a polygon is. And also, it has at least 3 sides. So when we talk about similar polygons, we are talking about polygons that have the same shape, but not necessarily the same size. All right, so let's talk about the definition of similar polygons. So the definition of similar polygon says if we have 2 polygons, they are similar. By the way, this is the symbol for similar. So are similar if and only if, so I didn't miswrite that. That means if and only if, which means it works both ways. We can flip the hypothesis and conclusion. If and only if their corresponding angles are congruent and their sides are in proportion. That would be corresponding sides. All right, so let's say that they told us ABCD is similar to EFGH. So here's what this means by corresponding angles and corresponding sides. So when I read this, A corresponds with E, first letter, B with F, C with G, D with H. Corresponding angles, corresponding sides. We can also do that. So angle A would need to be congruent to angle E. Angle B would be congruent to angle F. And angle C would be congruent to angle G, and angle D congruent to angle H. Now, they would have to tell us that these 2 shapes were similar for us to be able to write this. Or if they told us to, kind of force them to be similar, then we could set, if they gave us numbers and maybe some variables, we could set those equal and solve and find the value that would make them similar. All right, let's talk about sides are in proportion. So there's my corresponding angles congruent to each other. Sides in proportion. Sides we name with 2 letters. And so let's start out with side AB is to EF. So the division of that's the ratio, dividing that gives us the scale factor because these are proportional to AB is to EF as BC is to FG. So then I chose the next 2 sides, BC and FG. Then guess where I'm going with this? CD and GH. That's exactly right. And notice I'm keeping the first quadrilateral on the top, and then the second quadrilateral is in the denominator. So now I have AD and EH. All right, so once we set these proportions up, now that they've given us some side lengths, we can find out what the ratio is of AD to HE. So AD to HE is 8 to 6. All right, so for these figures to be similar, since they told us they were similar, the scale factor is the same for each side. So it's a 4 to 3 ratio, or the scale factor is 4/3, which means when I look at DC and this missing side, we'll call it X, I can set up this same proportion, 4 is to 3, as 25 is to X, and I can actually find the length of this side. So when I cross multiply, 4x equals 3 times 25, which is 75, or x is 75 divided by 4, which 4 will go into 75 once with 3 left over, and 4 will go into 35 8 times. Let's try it. Yeah, 8 times, which is 32 with 3 left over. So 18 3/4 is this side length. So you can pause the video and try to find the other two sides. So the next one would be CB and GF, and then go ahead and get AB to EF. All right, so now that you're back, let's go ahead and look at CB and GF. So we know that this ratio is a 4 to 3 ratio. So 4 is to 3 as, let's go with the pink, 12 is to X. So cross multiply, 4x equals 36. Divide both sides by 4, x equals 9. And then working through the last side, 4 over 3 equals 20 over x. So finding this missing side. And cross multiplying, 4x equals 60, or x equals 60 divided by 4, which would be 15. All right, so we found all the missing sides of that quadrilateral. And we see how to set up the angles that are congruent to each other and then the sides that are in proportion. All right, so let's keep moving. So here's my question for you. Are these two figures similar? All right, so the number one thing we want to check, corresponding angles are congruent. Well, this is a rectangle. And all of the angles in figure number 1 are 90 degrees. All the angles in figure number 2 are 90 degrees. So the answer is yes. All right, now the question is corresponding sides are proportional. All right, so let's check that out. So 4 is to 5. So now think about this. If this is 4, excuse me, 8. If this is 4 and this is 8, it's twice as big. 4 times 2 is 8. How does that work with the other side? 3 to 6. Yeah, 3 times 2 is 6. 4. So my scale factor is 2, or it's 2 to 1. Now, can we write the similarity statement, which is kind of like our congruent statement from before? Let's see if we can. Let's go ahead and label this A, B, C, D, and then E, F, G, H. All right, so quadrilateral, or rectangle in this case, A, B, C, D is is similar to E, F. So A, B, and E, F go together, so we want that first. E, F. And then BC and FG go together, so G would be next, and then H. So you can always double check to make sure your sides match up on that. All right. Next one, are these two figures similar to each other? And you may be like, hey, Coach Lowe, there's only one figure there. I think you're going a little crazy. Well, I might be, but there are actually two figures here. There's a large triangle and then a smaller triangle. So let's see if they are similar to each other. So this says angle A is congruent to angle B. They're both marked the same way. Angle E is congruent to angle D because they're both 90 degrees, and angle C is congruent to itself. So this angle belongs in the little triangle and the big triangle. So number one thing that we're going to check, corresponding angles are congruent. Yep. All right, number two thing we were going to check, are the sides proportional? Well, I don't know anything about this side, but I do know about the base of this triangle and then the hypotenuse of the triangle. So let's check that, the hypotenuse. So I have big triangle AC over little triangle BC. So I have AC is 26, BC is 13. That's a 2 to 1 ratio. Let's see if it's the same on the bottom. It looks like it is, doesn't it? So all the way across, 12 plus 12 is 24 over the little part, 12. So yes. Similarity statement. triangle AEC is similar to triangle BDC. Make sure they match. A goes with B, A goes with B. E goes with D, E goes with D. C with C. Yay! All right, let's keep going here. All right, last thing. In the figure below, trapezoid ABCD is similar to trapezoid EFGH. Use this information to answer exercises 5 through 9. All right, so pause the video and you guys should be able to do all of these things. So go ahead and pause it and try them out. All right, so now that you're back, the pairs of corresponding angles, we see that angle D and angle H go together. And we can go from here to make sure angle D and H go together. Angle A and E go together. And you can go ahead and write it like this if you want. Since they told us they were similar, we know that those are congruent. Or you could just make a list. Since they said just list the corresponding angles. Let's see, what else do we have? How about C and G? And then how about B and F? All right, 4 ratios with the corresponding sides. All right, so AD is with EH, AB is with EF, BC is with FG, and finally DC is with HG. All right, write a proportion to find the missing measure X and then find the value of X. So we see that here, and we see that we're given these sides and we know that they have to be proportional. So I'm just going to come down here for number 7. So X over 6 equals 8 over 12. Notice I did the smaller figure here. It has to be on top here as well. Cross multiply. So 12 times X equals 6 times 8. So 12X equals 48, or divide both sides by 12 and X is 4. All right, so there's the value of X. X equals 4. Now we're going to find Y. So Y is here at the bottom. We know the ratio is 8 to 12, so 8 over 12 is equal to 11 over y. So 8 times y is equal to 12 times 11. So 132. So y equals 132 divided by 8. So 132 divided by 8 will go once. So 52. 48, that's a 4, so 4 8, so 16.5 for y. And then let's go ahead and find z here. So 8 over 12 equals 5 over z. So 8z equals 12 times 5 is 60. Or z is 7 and 4/8 or 7.5. All right, so that's how you find the missing measures. We can also find the perimeter. Once we have found, even if after we've just found X, since we know the ratio of the two, we can actually find the perimeter from there. So that's an interesting thing. Let me show you this without even doing all of that over there. So 4 plus 8 is 12 plus 5 is 17. 17 and 11 is 28. So perimeter is 28. Interestingly enough, since we had that 8 to 12 ratio, the perimeters are in that same ratio because we're just talking about side lengths. So you can actually set up your proportion like this and find the missing perimeter. All right, guys, we'll work some more when I see you in class next time. This is Coach Lowe, and I'm out.